We will introduce the engineering pack with an example on how to disable the ALSIM built-in autopilot module and replace it with a custom Simulink model. From the Simulink diagram, read the state of the autopilot on-off push button. When the autopilot is switched on, switch on the AP button light. Blink the Alt button light. Maintain the initial aircraft altitude, share the target altitude in the FTD, and maintain a 0 roll angle. The first step is to write an INI file to list the simulation variable to connect. List the variable to read from the simulator, the AP button state in the in section, and the variables to write, the lights and autopilot state, in the out section. Then create and configure the Simulink model. Here we set an infinite simulation duration and a fixed step size of 33 milliseconds. Now browse to the ALSIM library and add the template block that allows us to read and write simulation variables. In the block parameters window, we insert the INI file we just made. The block automatically creates input and output ports for each variable in the INI file. For convenience, we separate inputs and outputs into two different blocks, using the dedicated block parameter to filter sections of the INI file. We create the sample time parameter and create the second block to manage outputs to the simulator. Now, let's manage the autopilot on-off button. To detect the push button rising edge, we use a triggered subsystem. This subsystem will only be executed when a rising edge is detected on the reading from the button. We skip the actual wiring of this subsystem. The subsystem input is the autopilot on-off state from the last step. The output is the new autopilot on-off state. The on-off state is toggled using a switch. The signal from the push button is 1 idle or 2 pushed. It needs to be between 0 and 1 to trigger the subsystem. An offset is applied to the reading from the simulator. An offset is also necessary to drive the lights, 1 off, 2 on. To make the alt light blink, we drive it with a square signal from a pulse generator. When the autopilot is on, a switch sends this signal to the alt light port and 0 otherwise. Finally, the autopilot state signal is connected to the autopilot on variable of the simulation network. In the ALSIM library for Simulink, the network sync block allows us to update the simulation variables we read from right to the simulator at each step. A block from the MathWorks file exchange is used to slow down the execution of the Simulink diagram to near real time. Now we rearrange the diagram and add a scope to monitor 3 variables: the AP push button position read from the simulator, the autopilot on-off state, and the alt light signal written to the simulator. As we are replacing the autopilot with our Simulink model, we need to disable the built-in ALSIM module. The ALSIM interface function has a command to achieve this. It can be called from the Matlab command window. Then we can start the Simulink diagram and check the behavior in the simulator. The second part of this example is to manage altitude holding and 0 roll angle. Let's check the updated diagram. We get the current altitude and roll angle from the simulator. and send the pitch command, roll command and current target altitude. The target altitude is selected when the AP is switched on. The value is updated on each rising edge of the AP push button. The pitch and roll commands are computed using classic PID controllers. Their design is really basic for this example. We could implement and test different control laws. The INI file has been updated to get the new input-output ports on the ALSIM interface blocks. We can also create Matlab scripts to start and stop the Simulink system. Let's start this system. The scope on the diagram now monitors the altitude, the autopilot pitch command, the roll angle and the autopilot roll command. We can check the autopilot state with the indicator on the PFD and the ALS light. When the autopilot is active, the commands are ineffective.